Okay, we have a MacBook Air. It says not charging battery. I'm not sure if you guys can see that. It says no charging battery, and also the description, the further description here says Mac doesn't power on with charger, only with charged battery. Okay, so this is a MacBook Air. As you as usual, let's take out the back cover, get an idea of what we are dealing with. Now, when you are working on these devices, it's very important that you have um, you other than the repair itself, it's important that you know the device very well. You know what year the device is. You know what are the common failures of the device, and also it's important that you understand the description correctly. And also, it's important that you are able to now define exactly the state of the device. Because if you don't have a proper definition of the state of the device, you won't know where to start, or you won't know what to do, or the actual next step to take. And usually, you don't want to go around the circle, and also um, you don't want to start on a wrong footing because that will completely throw you off. Okay, the back cover is out. Uh, this is a 2013-2014 MacBook Air. One of the way we are able to tell that is because of the JTAG connector here. As you guys can see, if you also remember in my previous videos, where I explained the basic ways you can tell the difference between a 2013-14 and a 2015-2017 board. So one of the ways you can easily spot a 2013-2014 board is the JTEC. So this is indeed a 2013-2014 logic board. MacBook Air. Let's test it out. By the way, this is not part of the repair. I just like to make sure that my machine is cleaned. So yeah, this has nothing to do directly with the repair. So that is done. Now what we want to do is we want to connect our charger to see if we have charger communication. Oh, by the way, the job is obviously has been pre-diagnosed. So um, yeah, the description that you saw there was obviously from a technician who has already done the assessment. So I'm just gonna connect the charger and see if I have charger communication. I don't have charger communication. Now the next thing I want to do is also, as you guys know, there is no LED. Now the next thing I want to do is I want to see if I have charger voltage in. So I press switch my multimeter to voltage mode. One of the ways I can confirm that is to see if I have my PP3B42 present. Okay, sorry guys, I need to also open up the board view for you guys so you guys understand what it is that I'm trying to do. Now the board view is 8203437. Let's go to 8203437. That is the board view. 3437. Where are you? Okay, it doesn't. Okay, let's check here. Should I have 3437? 34, 37, 34. Here you go, 34, 37. Okay. Um, that is the board view. Let's flip the board, okay, and then to the other side. Okay, so now the next thing we want to do is with our charger connected, we want to see if we have our charger voltage in on the device. So one of the ways, that is a way of basically trying to confirm if our DC jack is working. because if the DC jack is not working, obviously there will be no communication. If we get any type of voltage at all, if we get at least 3.3 volt on our logic board on the P3V42 output, which is this L7095, if we get P3V42 here, then it tells us that we do have voltage in on the board, because if we didn't have voltage in, we would not be able to get our PP3V42. So let's now check if we have our PP3V42. Okay, we do have our PP3V42, that's 3.4 volt. The next thing we want to see, let's see what we have on our PP bus. We can measure our PP bus on this fuse here. Now, on our PP bus is, let's see, so depending on what we have on our PP bus, that will give us an idea of what we need to do, and that will also give us an idea to if the SMC section that it's running, that basically, so if the SMC section is running that and then our PP bus is 8.6, for example, then we know what to do. And if our PP bus is going to be 8 point, it's lower than the SMC interaction on the PP bus level, then we know that we have to basically check out our PP342. We check out our SMC reset signal, and then also check out the SMC circuitry. So let's see what we have on our PP bus. Okay. Okay, PP bus is 0. Okay, let's switch it back to 20 volt. Let's confirm again that we still have our PP342. Okay, 3.4 volt is complete. It's complete and present. And 0. That is 0 volt. Okay. Now let's disconnect our battery and then try again. So we disconnect our battery and then connect our charger again. Let's just check again. PP342 present. Yes. PP bus present. No. Now let's see if we have a short on PP bus. PP bus is not present. Now let's switch our multimeter to continuity mode. Our black probe on ground, and then our red probe on one side of the fuse, and that side. Okay, so we are trying to confirm if we have a short, and we just confirm that we do not have a short. So the next thing we want to do is we want to take out our logic board and then head over to the area of U7000. I'm just going to show you guys. So U71000, it's the section of the logic board that produces your PP bus. So that is your charger and your battery, regulator IC. So let us head over to that section of the board and get an understanding as to why we do not have our PP bus. I mean, we have already checked that we do not have a short on our PP bus. I mean, if we had a short on our PP bus, that may not be our primary concern. But now that we indeed confirm that we don't have a short on our PP bus, so the next thing we want to do is we want to head over to U7100 to find out why PP bus is not being generated. Now, it's very important that you understand your steps. So now we have confirmed that we do not really have issue with our DC jack or our this IO board cable, because if we do have issue with the DC jack, in this particular situation, we will not even have voltage in, but we do have voltage on the machine, and we have our PP3V42. What we do not have is our PP bus. So, which is why we're now heading over to our section of U700, U7100. I'm taking out the board. Okay, the board is out. Put the shell on one side. Now let's see what we have. So now this is why we do not have our PP bus, and also it's very much of the same reason why we do not have our charger communication. So let's see what that section of the board is. I'm not sure you guys can see that. Yeah, that's so that is the section of E7100, which is our charger IC as well as our battery. Now let's see what it is that was affected. Okay, so what's affected here? It's okay. So one, two, three resist. There's three resistors are obviously affected. So the first one it's charger AC in. The second one it's PPDC in underscore G3H underscore ISOL underscore charger AC in. That is also affected. And then the next one is with our charger underscore ICOM underscore charge and pin one, and then the other side becoming charger underscore ICOM underscore R. So primarily our main issue is going to be our charger, our PPDC in, and then which is our charger AC in. Um, Currently, we should find it low. Currently we should find it low. Let's just grab a DC jack. Now that will explain why we do not have PP bus. That will also explain why we do not have charger LED, and also that will explain why. And by the way, so whether the ISL is present or not, you will be able to power the machine with a battery. Sorry. What I mean by what I'm trying to say is whether the ISL is present or not, you will have the voltage from the battery when you connect the battery to the machine. So, which is why the description says you can power the machine with a charged battery, but you are not able to power the machine with a charger because you cannot. The machine will not be able to start with the charger, and the machine will not also be able to charge a connected battery. So now let's see. I charger AC in is supposed to be around about 4 volt ish. So let's see if that is the case. But as now, given the state of the pull up resistor for the charger AC in, I suppose that signal is going to be low. Let's head over to we can measure that at the okay. Let's see, switch our multimeter to voltage mode. Let's measure that. We can measure that on this cap here, C7111, which is this. C7111 is still pretty much in shape. Uh, show you guys that. That is C7111. Let me show you guys can see that. So focus. So that is C7111. It's pretty much still in place. Okay, it's not even present at all. So that is going to be our primary issue why we do not have charger communication as well as, let's just check again if we have PP342. Yes, we have PP342. So what we want to do now is we want to um, remove and replace the faulty resistors in that section. Okay, so we are basically taking out one, two, three. So this has to go, this has to go, and then this has to go. Now, PPTC in, let's see. Okay, let's clean that section. Components are out. I am basically preparing the section for new components to be replaced. Some of the TP part are also a point of concern. If you guys see this here, yes, so that's a point of concern. Focus, okay, yeah, that is a point of concern, and then also this. So what that means is even after we replace the resistors, we need to confirm that we have continuity on those lines. So the part that seems to be off is charger icon. Right now, we will not really be worried about that. What we are worried about is R7110, which is PPTC in, and apparently PPTC the pin one of R7110 is completely off the board as well. I'm just going to show you guys that. So um, so this is one resistor. This is the second one. This is the second part of the second resistor. However, Let's start here as well. That's the PPDC in. So that is a pad that basically you get a PPDC in voltage from, which explains exactly why we had completely 0 volt on our charger AC in. So we need to okay, let's see. Hmm. Okay. So what we're going to do is this is the next point where we can get our charger PPDC in voltage from. So what I'm going to do is I'm going to attach a resistor here, and then use a wire to output the voltage to charger AC in here. So I'll just stick. So which means let's resist the resistor here that was supposed to be at that was supposed to be here. Since we don't have a pad here, I'm going to install the resistor here and then use a wire to bring that voltage to this section. Or we can install a resistor here and then use a wire to bring to basically make connection with our PPDC in voltage. Either way, it's fine. Yeah, let's do the other one. We can, yeah, let's just put the resistor here. So we place the resistor here, and then we then use a wire to take the voltage to the other side. Right. Our, scrabble, no board. And now we use a wire. So right now we are not worried about charger icon. So that is that is that line allows the ISL to that line allowed the ISL to tell how much current the charger is pulling. We're not really interested in that line at the moment. First, we need to get our PPDC in active. Our PPDC in voltage needs to go to our ISL. Then we can worry about uh, yeah, and then we can worry about the other line. Trying to prepare a wire to use. Okay. So right now, what we want to do is so our resistor is in place, and then we have a wire to the output uh, of the resistor. Now, the next thing we want to do is, like I said, we're not really worried. Among the three resistors that were out, one of them is charger underscore icon. We're not really worried about that. The next, the main resistor that we're worried about, and the pad that we're worried about, is the R7110 for PPTC in. And then the other one, the other resistor is charger AC in output and ground. We are also not worried about that at the moment. So let's see what we now have on our charger DC in. And then, as always, we want to disconnect our fan because we like to only have our fan connected when we confirm that the board is working. Because I cannot, the anxiety will kill me, expecting to see a fan spin. Okay, let's see what we have now on charger AC in. Now, um, that we can tell the changes from what we will now have on our PP box. So if we have changes, if what we did any made any changes, our PP we should have changes in our PP box. So let's first of all let's see what we have on our PP 3.2, 3.5 volt. Let's see what we have on our PPDC in. Now 8.59. So now we have our PP box. So at this moment we should have a fan spin as well. Let's just see what we have on our. Let's just see what we have here. Okay, L7520. That is an SO rail. Let's see if we have 5 volt on that coil. Yes, we have 5 volts. So that tells us that our board is starting. So now I can connect my charger. Sorry, I can connect my fan, and I should have a fan spin. Just gonna show you guys. Okay, that is the fan spin. Now this is the 2013-2014. The fan is gonna start and stop, and then start again for the second time, and then stop, and then the third time when the fan starts, it should continue running. So that is the one of also the difference that you can see on the 20. Okay, let's just see that. We're not sure why it stopped. I'm just going to do that again. Okay, so let's see. Oh, by the way, yeah, we need to put back the other resistor for the icon. Yeah, we need to put that back. So at least right now we see that we have our PP box and our board is started. So the next thing we want to do is we want to put back the other resistor that was also faulty alongside the ISL. Okay, you see the board is starting. We will put back the other resistor, but I just want to see if we have Apple logo. Just want to see if we have an Apple logo before we put back the other resistor, and also properly put the wire in place, the jumper wire. Oh, by the way, there might be, you guys will see channel communication here. That is because we do not have the IO board cable. So if the IO board cable was there, we would definitely have a charger communication LED. Okay, that's the third time. Let's see, do uh, we have anything on the display? Yes, that is an Apple logo. Okay, this is good. So the next thing we want to do is we want to put back our charger, which let's see, we want to put back, uh, yeah, R7142 needs to go back. And what else? What else? Okay, I'm just going to show you guys that now you have charger communication. Although that is, I mean, that's lame. I mean, you you guys can already see that the machine now starts without the battery. But I just want to show you guys that you have charger LED. The reason why that was not the case, as I'm not sure if you guys can see that, that is our charger LED. The reason why that was not present before just now was because we didn't have this cable. So with this cable disconnected, obviously you will have, now with the cable disconnected, you will not have charger LED. Even though the machine is still going to start, don't worry, don't mind that. Don't mind that. It's yeah, don't mind that. It's not supposed to be that. So ideally, the way this is supposed to be, it's supposed to move from green to amber, but just straight amber, it's basically not a communication. It's a carryover from the previous. So this is how it should behave when this is present. It should get green and then amber. Just going to connect that for you guys to see. So it should get green and then amber. Yeah, that is how it's supposed to communicate. Now, when this is not there, you will not get that communication. There will be no LED on the charger. The LED that you got on the charger will basically carry over from the previous LED with disconnected. So let's what we want to do now is let us put back RE7142 and then finalize the repair. And then something else on R7142, this part here is also missing. So we need to also recreate that. Okay. We have put back. So we have put back R7142. The next thing we then had to manually recreate this pad. We had to put a solder blob here and here. So what we want to do now is we want to confirm if we have continuity between pin 1 of R74 2042, so R7142 and pin 5 of our ISL. Switch our multimeter to continuity mode and let's hope to have a beep. Okay, we have a beep and that tells us that the line is fine. So that then the next thing we want to confirm is let's see if we have continuity also between C7142 and pin 2 of R7142. And yes, we do. So that is going to be the end of our repair. I'm just going to show you guys how that looks. I'm still gonna fix it. In terms of, I'm still gonna clean it and then so okay, let me clean that just a little bit. Okay, see the way it looks. We're still going to okay, now you see the way it looks. So we had to run the wire. So we put a resistor here for PPDC in, and then put a wire to run it to the output of our charger AC in output. And then that's the second resistor for the icon, and then that is the solder block for the case. The focus is not that good. Let's see if you guys can see that. Yeah, I'm not sure if you guys can see that. Okay, yeah, pretty much that is what we have to do to fix the problem. And yeah, so right now we just need to make sure. Hmm, make sure we don't have any breached line. Okay, don't have any breached line. Let's put a small protection in place of the jumper wire. Okay, that's the board again. Uh, I just hope my audio was not stopped. That'd be really bad, which means I have to redo the audio if it was stopped. Okay, so as we can see, we are charging. So there, says battery is charging. Okay, we just this is complete and we are done now. Give the battery a little bit of charge and then this can be finalized and the client can collect. Yeah, that is another happy client. Thank you guys. See you in the next video.